Check, check, check. Hello, hello. Welcome to another episode of welcome to another freaking physics. And yep, Ariana's here. Let me just get in. All right, so we're doing math. Yeah, and I'm kind of checking the sound settings right now. So let's just see how it goes. Oh, I have a lot of dropped frames today. So hopefully the stream's good, but let's see. All right, so I'm gonna let her in now. Hello, Ariana. Good morning.
Hello.
Hello. So, how are you today?
I'm good. How are you?
Doing good. Thanks for asking. Uh, my internet's a bit unstable right now, so I'm unable to load the board as of the moment. But I did get the worksheet
Okay.
that you sent me. All right. So what we'll do is while I'm
Mhm.
waiting for the board to load here, I want to ask you a couple of questions first before we do anything. Okay. Now, basing on
Mhm.
the wording of the problem, I'm going to assume that you have just learned about the exponential function using the number e as I introduced last week.
Yeah.
Right. So, any questions on how to do that exact the exact process? Uh-huh. Okay, there we
It's
go.
just.
All right. Sorry. I finally got my frame rate to improve, so I think I should be able to load the board.
Okay.
All right. So while I'm doing that, any questions on the techniques or whatever with that particular form?
I just have like. I don't really have any questions right
Mm-hmm.
now, but it's just like. I'm just like a little confused. Like.
Okay. So it's just really more on how to use it, right?
Yeah.
Okay. All right. So I got that. So we'll go. Okay. I'm gonna put the board up now. We're using the same board again. Hopefully, I can load it soon. I really think it's just my internet connection because I'm dropping a lot of
Yeah.
frames
I'm
right
in.
now. Yeah, I'm dropping a lot of frames.
Hmm.
So that means the internet's a bit unstable. Do I have my phone here with me? Okay, this is what I'll do. I'm gonna try to change hotspots first, see if oh never mind, my battery's too low to do that. Alright, so alright, either way, I do have the document open and I think you do too. Uh okay, for those forms wherein it's not in the form actually
Mhm.
most of them are in the form of the in the form of N0EKT, right? Okay, so uh
Mhm.
okay. Just double that though? No, alright. So okay, so what we'll do either way is we'll go to the problems right away. Okay. Um
Mhm.
alright. Let's let me just refresh this thing again. Okay, so that's in. And let's go to my boards. All right. If this doesn't work in the next minute or so, I am just going to discuss share this document here, all right? And we'll go to the problems one by one. All right, I think it's loading properly now.
Mhm.
Give me another moment or so. You know what? I've been trying to load this for the last 10 minutes. It just won't do anything.
Oh.
Yeah, I think I may have to buy, add on to our internet connection, see if that improves it to the speed. All right. So anyway,
Oh.
yeah, anyway, so let's go to number 1 right now. So, uh how will I do this? Okay. For now, I'll do it like this. Okay.
Like get on like.
There we go. And
Okay.
I'll just zoom into that. All right. So let's go to the first problem here.
Uh.
Um so you have an overfished area and the catch is decreasing exponentially and you're given the value of k, right? So let's go with there we go.
Mhm.
So how would you use this? So okay, I think I'll show you how to do this first. Okay. Where's my pen?
Mhm.
Nope, not underline. Draw. Okay. All right. So the idea here is you're always gonna use the equation n. Oops. Equals n0 e raised to kt. Okay. Um,
Mhm.
it is not working as I'd like, so I'm gonna try this. Kt. All right. Now, what would you do with the k? Okay, k would be whatever value you have. Okay, but um, but you're gonna have to use the positive value for growth. Okay, and then the negative value for decay. Okay, so again, the
Mhm.
okay. You're gonna use. Let me redo that. N0 e raised to k t. All right. So again, that's always what you do, and then after that, you just put that in the calculators and stuff. Okay. Okay. So let's remove
Mhm.
everything. Let's erase everything I've just written. So I'm going to just okay. Let me see now the board. Not enable. Reconnect. I'll try that again. Right. So let's kind of do this here on the actual problem. How to apply that. So n0 would be the initial amount, and n would be the amount at certain time t. Okay. So in this particular case, all I'm gonna do now
Yep.
is I'm gonna do n equals n0 e raised to negative 0.84 0.84 rather 0.84 t. That's all you're gonna do. Okay, and it says here that you're looking for the
Mhm.
time that we're in the new amount n is half of n0. So I'm just gonna change this. I'm just gonna change this n to n0 over 2. All right.
Mhm.
Okay. So what happens because of that? The n0 here cancels out with this n0 here, and then we're gonna be left with um 1/2 equals e raised to negative 0.84t. Okay. Now, the thing about e, and this is the thing
Mhm.
that you need to,
And.
the thing that you need to do is again, um, you're gonna take the logarithm of this just like before, right? But what you do now is you take the natural logarithm ln. So I'm going to do that 1
Mhm.
half. Okay. Now, if I take the ln of e, so basically this becomes, if you follow the rules of logarithms, this simply becomes negative 0.084t, oops, 0.084t, and then if I write it in full, that's gonna become uh, ln of v. But this just basically cancels out to 1.
Mhm.
Okay, so again, so in your calculator you do have the natural logarithm button. From there, calculate ln of 1 half and find t. All right. Okay, let me see first now if the board has properly loaded. This is frustrating. Okay, I'll just do a clean board for now.
It keeps on saying that you join, and then like, all right.
Okay, that's really weird. I'll refresh that. Okay, one more on my boards. This is my last attempt for a while. Okay, hold on. So, okay. So that's clear enough, I hope. So while we're trying for, okay, I see that you've joined the board, but it still won't load on my side. Okay, so from here, what are we
It says
gonna?
that you joined the board.
That's really weird. So anyway, so let's just do it here quickly. So what do we get? ln of 1 half is, where's my calculator? Okay, so of that, where is it? Here. That's gonna be negative 0.6931, and then
Does it depend on whether we're on radians or degree
it
or
doesn't.
no?
It doesn't. The natural logarithm is it's not a
Okay.
trigonometric function, so it doesn't matter. Okay, so then divide this by
Mhm.
negative 0.084, and oops, sorry, divide this by negative 0.084. Let's put the negative in there, and our final answer for the time is 8.25. Okay, so t equals 8.25.
I got that too.
All right, great. Okay, now
Mhm.
in this case, what's the
I got that.
difference?
Yay.
Yeah, great. Okay, so in this case, what's the difference of this versus using the older forms of the exponential function? Okay. Uh okay, it's gonna be much easier to see it if you're looking at certain things like growth, natural growth, right? If you think about this, or natural decay. If it's natural, it's not really they double immediately after a certain amount of time. They increase a little bit at a time until
Mhm.
eventually just double, right? And in that
Mhm.
case, in the more mathematical sense, if you do it like that, if the situation's like that rather, then it's gonna be more accurate to describe it with this equation rather than the ones that you've learned before, even though you'll get the same answers. Again, this is the more natural
Okay.
way of saying of doing it. Okay, even though again you'll get the same answers. All right, so hopefully that's
Mhm.
clear. Now let's see if my board has finally loaded. No. What if I cancel and I write? Can you see what I'm writing if I do that?
You're not in the board.
I'm not in the board at all. All right, and I'll try it one last time. If this still doesn't work, I'll put this in the board later when it works. Okay. All right, but
Okay.
all right.
Gotta
Anyway,
figure it out.
yeah, I gotta figure something out here. Boom, boom. Okay, I think I'll be fine. My internet connection just jumped. Okay, so anyway, let's go back. So
Ooh.
since you did it properly, so that means yeah, you do get what you have to do. And basically that's all you have to do for all of these questions. It's the same thing over and over and over again. Okay? All right. So which ones haven't
Mhm.
you done yet? Which one haven't you done yet?
I mainly did the fronts. I mainly did the front side that I remember, like the eight skill practice.
Mhm. Right?
Besides 7B.
7B. Okay. When does the population reach 1,000, right?
Mhm.
This one. All right. So how would you answer that bit? All you have to do is this is going to be your value for P of t. And then you're looking for time. Okay. So again, that's your P of t.
Okay.
Look for time. Look for
Mhm.
time. Okay. So how will we do that now? So basically we're going to do 100,000 rather is equal to 105,000 all over 1 plus. That's an interesting number to have chosen. 2.7 is quite close to the value of e. 2.7 e
Ooh.
raised to negative 0.0981 t. That's another interesting number to use, 981. That's like gravity, right? So from here,
Mhm.
I'm
Oh,
going,
like.
yeah, you see what I mean, right?
Mhm.
Okay, what I'm gonna do here to make it a bit easier to manage is I'm gonna cross out that thousands, those three zeros from the thousands, right? Oops.
Mhm.
All right, and then uh, what are you gonna do? I'm gonna just flip this over. This is gonna be over one, right?
Okay.
So if I flip that over, that's gonna become 1 over 100, 1 over 100, 100 here, is equal to, uh-huh, is equal to, we flip that 1 over as well, 1 plus 2.7 e raised to whatever. I'll just write whatever for now, right?
Mhm.
Okay, all over 105. So from here we can just move, we can more easily move stuff around. We'll move that 105
Yeah.
first, so we're gonna be left with 105, 105 over 100 is equal to 1 plus 2.7 e raised to whatever t. Okay, then again, as
Mhm.
usual, solve for t. Um, by we can move that one around and this 2.7 to the other side and then find the ln of the whole thing. Okay,
Mhm.
all right, let's connect that. So okay, yeah, that's really, I don't know what's happening. So let's just put that in the calculator. So that's gonna be 105 divided by 100. That's gonna be 1.05, right?
Oh, mhm.
Um, so let's just zoom in. Let's just put it here, I guess. Put it here on the margin. Okay, so that's gonna be 1.05 is equal to. We're gonna. I'm just gonna shortcut 0.05. So this becomes 0.05 equals. I'm gonna put here over 2.7
Mhm.
is equal to e raised to negative. Okay, I'll write that. I'll still write that as whatever for now, right? Whatever t, right? Then finally get ln. So we do
Mhm.
Let's get that value. You know what? Yeah, let's just get that value. It's 0.05 divided by 2.7. Okay. And then I'll get the ln or right away. So this is gonna give us negative 3.99. Okay. Negative
Mm-hmm.
3.99 is equal to um 0.0 negative 0.0981t. Negative
Mm.
0.0981t. And then finally, our t here would be 3.99 divided by negative 0.09. Okay, 3.99 divided by 0.0981. Uh, that's gonna give us t equals 40.
Okay.
Okay, nearest 100, so that's gonna be 40.67.
Mhm.
Okay, so I'll just write it here. T equals 40.67. Oh, not
That
enough
was better.
space.
That was better
Yeah.
than what I originally got, which was like a lot of points, and I was just like, that is not correct.
Nah, 6 t equals 40.67. Okay.
Hmm.
All right. Quick check. Unable to connect. Reconnect. Refresh. Ah,
Should I leave the board?
yeah, just leave the board for now.
Okay.
All right. So is that? Let's see now. Let's see. Which makes sense, right? Because 100,000 is quite close to 105,000. So it shouldn't
Yeah.
take that much time, whatever this time is. If you think about this, a habitat, whether this is days or hours, 40 units of time isn't that long for a population of 100,000, right?
Hmm.
Okay, so this makes sense, right? Any, okay, you kind of get what to do here now for part B, how to do it.
Yeah.
All right, so let's do the
Hmm.
second page. All right, this is what we'll do.
Cute.
Okay, let's zoom out a little bit so we can see that. All right. Hmm. All right, these are all okay. Yeah.
Hmm.
All right. So which one would you like to do right now?
Um. Can we try the first one?
The first one. All right then.
Yeah.
Okay, go ahead. The first one. So, okay, let me think of another way to do this. Paint. Am I that desperate that I'm gonna use paint?
Like JS Paint.
Yeah, as in Microsoft Paint. Yeah.
Oh my
Uh,
gosh. Yes.
let me see if that works on the board here. And let's see. For now, at least. Again, I'll move this over to the sideboard when we're done. Okay.
Oh my gosh.
I know, right? I okay. Hold on. Give me a moment here. Let's add that to here. Window capture. Okay. Hmm. Okay, it is not showing on the board either, on the camera. All right.
Oh,
Okay, so I'm just not gonna do that.
okay.
Oh, finally it loaded.
Oh my gosh!
Yeah, finally. All right, so let's do it here. I'll try joining
I'm,
the board now. See if
I'm gonna like appear.
right.
I'm gonna like appear and you're gonna like crash
Hopefully not.
immediately.
Hopefully not. Okay.
Yay.
All right, there you go. I can see what you did there. Happy face. All right, so let's go to number one. Let's put it on the board. So how many hours will it take for a culture of bacteria to increase from 20 to 2000? Use a value of k equal to 0.614. Okay, still pasting, pasting. Come on, there we go. Yeah. All right,
Oh
so
my gosh, it's working!
finally. Great. All right, let's see.
So 2000 goes here and it's
Right.
by itself because it's
Mm-hmm.
the product.
Right.
Yeah. And then 20 goes here.
Right.
And then the E, correct?
Yes.
And then it's the K and then T, but the K
Right.
equals the that. I don't want to
Mm-hmm.
write it though.
Yeah, yeah, it's fine. It's fine. So
Mhm.
correct.
And then you divide both sides by 20? Yeah?
Correct. Yeah, correct.
Okay. Yeah. Oh,
So
whoopsie.
okay, so you're getting the
And
trick now, right? Okay.
mhm.
Just
So
gonna give you
1
100.
equals E and the
Mm.
0.614 T.
Okay, great.
And then you can make the ln state thing, right?
Yes.
Okay. It's weird. It's weird that it's ln because natural logarithms, logarithm natural.
It makes sense if you think about it. Not in English, because when they wrote about who came up with the natural logarithm, I think it was no, Bernoulli was the one who discovered it, but the one who came up with it mathematically was Euler. And Euler was really fond of Latin.
Oh, okay.
Now, it makes sense now if you think about this in Latin, right? All
Yeah,
right, so
I
great.
can see
So,
it.
yeah, so that's correct.
A lot of Greek and
Mm-hmm.
Latin and like
Mm-hmm.
math.
Right. Well, it's because it was the language before before French took over, and then after French, German took
Oh,
over. Then after German, English took over.
whoa.
Yeah.
So ln 100 is a long number.
Mm-hmm.
And how many? It doesn't say how many decimal points I should go to, so I'm gonna do 3.
Mm-hmm. Yeah, 3 should be fine.
And then you would divide this by this
Mm-hmm. Correct.
to get T.
Right. Correct. Okay. I just wanted to make sure that it was indeed Latin. It is. Well, most probably Latin. There's
Ah.
no one actually knows if it's from Latin though. If it's Latin, it's basically if you translate that to English, it is natural logarithm still.
Oh, okay.
Okay. Logarithmus naturalis.
Ooh.
All right, correct. 7.5 hours.
Yay.
Great. Okay. All right, let's go. Okay, I'm gonna show you a quick check. Just a quick check. Okay. This check doesn't
Quick
really.
check.
Yeah, this check doesn't involve this, but this involves a bit of reasoning. Yeah. So it says.
Okay.
Okay. It says here in 7.5 hours, it goes to it goes to 100 times like that, right? And 100
Mhm.
is close. What power of 2 is 100 close to? That's 128, more or less, right?
Mhm.
Okay, this one is not.
Yeah.
This one's really more really checking whether it makes sense or not. Okay, so back in this case, 128 is. I'll
Mhm.
write that here. 128 is equal to 2 raised to 2, 4, 8, 16, 32, 64. 2 raised to 7. Okay,
Mhm.
so this is approximately. So this is basically So let's go back here. So this basically means it population doubles population doubles every hour.
Ah.
Doubles um okay. 2 raised to 7. Comparing here every hour. That's what okay, because this 7.5 here and 7.5 here approximately every hour. Okay? So
Mhm.
okay, now does that make sense in terms of a culture of bacteria doubling its population? Kinda does. Some bacteria can double in every 20
Yeah.
minutes. But most would take about an hour. Okay, so this
Mm.
answer makes more a bit of sense. All right, let's go to number two. This time it's half life. It's decay, right?
Mhm.
All right. So this your substance here is radioactive and it has a half-life of 32 years. So you need to find the constant K on the decay formula. Find the yeah. Find the constant K of the decay formula. Any idea how to do this?
Uh.
Okay, how would you
Yes.
do it?
Isn't that like the one with like where you put like the n in the half and then
Yes. Yes, because of the term half-life. Yeah.
yes.
Okay, great.
Mhm.
So
So it'd be
go ahead. Mm-hmm. N over 2 equals. Mm-hmm.
E
Mm-hmm.
32 K.
Right. You for okay,
Hmm?
that's fine. That's fine.
Did I forget something?
Uh Not really, but kind of. Depends on how you look at it. But just go
All right.
ahead. Just go ahead and solve for K here.
All right. Explain to me later.
Yes. You can still solve for it either way, so it doesn't really matter.
Mhm.
Mm-hmm. By the way, just so
Mm.
we're clear, yeah, ln of 1/2 is neg. You're gonna remember this number because you're gonna see this a lot.
Oh gosh.
Okay, but don't worry, you can always just calculate it either way, so you don't have to memorize it. But once you see it, okay, there.
1.6931.
Mm-hmm. 0.6931.
No.
All right. So correct.
Wait.
Correct. Carry on.
Okay. Was I supposed to put a negative on the 32?
Okay. Yes. Now I'm gonna say this now.
Oh.
Like I said, it doesn't matter because I think in the way you're learning it, the k has to be a positive number, and then you add a positive or negative sign whether it's decay or growth, right?
Ah, yeah.
Yeah. But if you don't do that and you get a negative sign on your k, then it automatically makes it decay. So in other
Mhm.
words, in this case, you will always get your K, and then you just have to change it to whatever form depending on whether it's decay or uh growth. Okay, there we go.
Yeah.
Okay, great. So this would be, I'll just make sure that that's correct. Okay, so, all right. So far that's correct. So ln of 1 half divided by 32 is that.
Mm-hmm.
Yeah, this is correct. Great.
Mm-hmm.
Okay.
Can we try the whale
The
problem?
whale
Because the
problem.
teacher was like, people get stuck on that, and I was just like, oh gosh, and I couldn't really. I was just like, what was I supposed to do? So
Oh,
yeah.
it's a, basically this is not really a whale problem. This is actually a half-life problem.
Oh.
So don't worry about it too much, about it being about whales, okay? Because look,
Okay.
uh, okay, I'll explain why it's a half-life problem.
Okay.
Okay, the idea here is carbon 14. I'll do some physics first before we do the math, okay?
Oh no.
Okay, don't worry, it's just a physics concept. It's no calculation, just a
Yeah.
concept. Okay, carbon 14 is radioactive.
Mm-hmm.
Okay, that means carbon 14 has a half-life, which
Oh.
which means it goes back to question 2. All right.
It all
Now,
comes full circle.
yep. The but in this case, you don't really need to know the half-life anymore because you already have a certain amount after some time, right?
Mm-hmm.
Okay, and you are given the K.
Mm-hmm.
So, in this case, let's go to the math now. How would we set up the equation? It's exactly the same way as
Okay.
before, where you have your n equals n0 e raised to, in this case, we'll put the negative sign now, negative kt, right?
Mm-hmm.
Okay, we have our k, so we can put it in. We're looking for t. We don't have n0 and we don't have n, but we do have that.
So the like 1/4, correct?
That's not 1/4, that's
Oh.
0.25%.
Oh wait.
So I'm gonna put that as 0.25 over 100.
Oh.
That, I think that's what's tricking most of you. That 0.25% is not 1/4.
Mm.
Okay. All right. So from here, solvable now, right?
Yeah.
Okay. Go ahead, solve it.
Hey, I'm just gonna rewrite it real quick.
Mm-hmm.
Mm. Wait. Actually, then the ends just cancel out, so I could just
Yes.
0.25 divided by 100 equals e negative. That's a lot of zeros. Okay, I like
Just KT for
doing
now.
like
Just do it as K, negative
sig.
KT.
Okay, and then we can just immediately put it into like the ln
Right.
0.25 100
Mm-hmm.
equals negative kt with ln. I'm gonna put that
Yeah.
in my calculator.
Just use your calculator here straight away to find T.
0.25
Mm-hmm.
negative 5.99
Right.
divided by negative 0.000.
Okay.
Oh,
Correct.
that's a big number.
It should be.
49,928.87.
Okay, great. Now, this is correct. Now, I'm gonna go back to the physics real quick. This number
Mm-hmm.
makes sense, okay? Because I'm gonna tell you now that I happen to know what the half life of carbon 14 is. Okay,
Oh,
Carbon 14, the half life is approximately. I'll make it easy for you to wrap your head around. The half life's around 6,000 years.
Mm-hmm.
Okay, so this is a very small percentage left, right? So in other words,
Mm-hmm.
it must be way bigger than 6,000, and that kind of looks correct, right?
A bit,
Okay.
only a little bit bigger than 6,000.
Yeah. All right.
Only a little.
So okay. You know what? I'm just real curious. I want to see what the actual half life is.
Ooh.
Okay, real quick. Yeah, the official half life value is 5,730 years. So
Ooh.
okay. So anyway, so that's the idea here. So yeah, I think most of you are making, according to your teacher, this mistake. Most of you are just writing this.
1/4.
Yeah, or just one fourth. All right. So be careful with the percentages. I like the way that this problem is presented. It really distracts you from what you really have to do. Right.
There's so many numbers.
Yeah. All right. So okay. We have. Okay. What other number would you like to try right now?
And
Five,
pull
six,
out
seven,
my
eight, nine.
paper.
I think we want to do nine later at the end.
Uh, I was like thinking like I want to do 9 at some point, but
Yeah.
maybe.
Yeah, we can do that
Yeah.
now. We can do that now.
Um. Yeah.
Because the rest, I think it's basically the same thing as the other examples, right?
Concepts.
Same thing
Yeah.
concept wise. It's just changing the numbers every so often. Now let's take a look here at number 9. This
Mhm.
is really similar to number 7 of the first page, right?
Mhm.
Okay. Um Here we go. Let's take a look at A. What's the maximum population?
Would it be like the 16,300?
Yes, it is gonna be 16 300, okay? But how do you know? This looks a little bit
Um.
different from what the logarithmic growth that you know. It's a little bit different because the E here is at the denominator and then you have a 1 plus part, right?
Mhm. Is it because the K is negative?
Mm-hmm. When the K is negative,
Okay.
uh okay, this is how I would do it, okay? I'm gonna look here and I'm gonna do either. So I'm gonna check either uh either t equals 0 or t approaches infinity. Okay?
Mm.
All right. In this case, when t equals 0, that just becomes 16,300. So I'll just put it here first. When t equals 0, p becomes 16,300 divided by 1 plus 17.5 e raised to 0, right? but
Mhm.
but that just becomes 1, so this becomes 16,300 over
18.5.
18.5. Now, I don't have to solve that. I'm just gonna leave it like that. Okay. Now I'm gonna
Uh
do
huh.
another one. I'm gonna do the other thing. I'm gonna do as t approaches infinity, p will become 16,300 divided by 1 plus 17.5 e raised to negative infinity, right?
Mhm.
Okay, but the thing is, since this is again mathematically incorrect, but at least it's a bit easier to see what's happening, right? But what happens here
Mhm.
when and this becomes negative infinity? This whole term becomes it becomes negative infinity as well, right?
Mhm.
Okay, So what does this mean? The population skyrockets. So, oh, sorry, the population becomes zero, right? Because a
Mhm.
number, any number divided by a much bigger number becomes approaches zero.
Mhm.
So this thing approaches zero. So in other words, this is our maximum population, and this is our minimum population.
Aha.
Okay. All right. So again, whenever you're looking for either a maximum or minimum population, you check either of these times. That's the easiest way to do it.
Uh-huh.
Okay. All right. So we just did A. This is the maximum population, but what's the value? Just calculate that.
Okay.
All right. So 16,000
Do
18.5 gives you how much?
888.1. I mean no, 881.
This gives us 881, right? Now
Yes.
that kind of makes sense, right?
Yeah.
Okay. Uh However, there's another thing you can check. Okay, you're gonna check now the denominator's minimum value. What's the minimum value of denominator, right?
Yeah. Zero.
Okay, the it cannot be zero. The 17.5 e raised to negative negative whatever time, that's gonna be zero. Okay,
Mhm.
so okay, sorry, I forgot to mention to get to this. So in this case, the minimum value of the denominator, it doesn't matter what it is, but that becomes p equals 16,300 divided by 1 plus 0, right?
Mhm.
So that's still gonna give you 16,300 divided by 1. That's still gonna give you 16,300. So that's how. So these are the three things we need to check. I forgot to get the minimum value. Okay. Now these two values don't necessarily give you the minimum value of the denominator. Okay. Now, having said that,
Mhm.
so the maximum population is still gonna be your. So this is actually your maximum population. Okay.
Mhm.
All right. So all right. So always. So what's the technique I add here, or that end check end check val check p. I'll put it here when um denominator has minimum value.
Mhm.
Okay. In fact, okay, so these are the three things you check. In fact, most of the time, this will give you the answer. Okay. All right.
Mhm.
So, okay, let's go back now. So, when does the population reach 16,200? So, let's go to B. So, when does the population
So
reach
yeah,
16,200? Okay, I'll zoom out a bit.
we made 200 equals. Oh wait, that's one.
Okay. All right. I'm gonna revisit something. I just realized I said something wrong. But okay, anyway, I'll revisit one of these things.
Okay,
But yeah,
like cancel these two out.
yeah, cancel the zeros
Okay.
out to make it easier. And then again, if you see this in the denominator, you also put the over one here, so you just flip them over more easy flip them over and should be easier to work with.
Mm-hmm.
Okay, so just
Mm-hmm.
so what value would you get?
See. Wait, do you flip the whole thing? Or...
Yeah, you
I
flip the
look
whole thing.
back. Oh wait.
Mm-hmm.
Okay. I just don't want to write K again.
Mm-hmm.
And then you times everything by 163.
Mm-hmm. Correct.
I'm gonna make this a decimal now because -1 just boop.
Mm-hmm.
Not rewriting all that. And then you divide it by 17.
Uh-huh.
I'm gonna use the E.
Mm-hmm. 10 to the minus. All right, correct. Okay.
Okay, what is the actual negative 0.0? Oh, yeah, the negative
Mm-hmm. You're 6,
65
5.
T,
Okay, correct.
and then you L, then you make the ln.
Uh-huh. Okay, I'll just put that negative there. It's not very visible. I'll just put that sign there.
Oh, sorry.
Yeah, it's fine. Okay.
That looks like a G.
Yeah, that's fine. Oops. My mistake on that one. All right.
And then this would be negative 7.94
Correct.
or 95
Mm-hmm.
divided by the 0.6
Right.
0.065
Mm-hmm.
T equals 122.3
Correct. Correct. Okay. So I'll
or just remove the 0.3.
okay. So again, in this case, whatever that t is, remember because the population here is more, it increases continuously. This you put in the point 0.3 there is okay. If it doesn't increase continuously, then yes,
Mm-hmm.
you just put 122. Okay. So again, I'll just
Okay.
before I go back there, let me just write that. So if your exponential function does not involve e, yeah, involve e,
Mm-hmm.
um, it may not necessarily, it's not necessarily true, but it may um, double suddenly. Okay,
Okay.
all right. But however, if e is involved, okay, if e is involved,
Mm-hmm.
then the growth is continuous and smooth. Okay, is
Mm-hmm.
continuous, smooth, and not sudden. Okay. All right.
Mhm.
So anyway, let's go back here to the thing I want to revisit before we end. Yeah, I was wondering where I made the mistake here earlier, so that's why I had to go back here, and I spotted the mistake.
Oh.
Yeah. All right. So this is
Mhm.
where my mistake is. So this is still correct, right? But
Mhm.
remember, but here's the thing: a is raised to a negative exponent, right? So
Uh huh.
this means that as so this means any number raised to a negative exponent is the same as saying 1 over e raised to that exponent here, right? That includes e as well.
Mhm.
So if you change this to infinity here, this becomes infinity, and this is just equal to 0. And this part is where you get your 0. So this is where,
Oh.
so you see what I mean? It still works whether you do 0, t equals 0, or t equals infinity. Okay?
Mhm.
One of them
Okay.
will give you your maximum or your minimum possible value. So in this case, we already see what our
Mhm.
maximum value is 16,300 from here. All right?
Yes.
Okay.
Mhm.
All right, so I think you get it now on how to do that properly. So, any
Yep.
questions?
Nope.
All
And
right.
the end of the school year is coming up in like a month
Oh,
or over a month now.
yeah, same with us actually, about a
Yeah.
month more. All right, so
Mhm.
afterwards, you're gonna be in DP after that.
Yeah.
All right.
I'm gonna be like help.
Yeah, I'm pretty sure you'll need help. So yeah, I'm still here. Okay, I'm gonna be here.
Mhm.
Okay.
I'll
For help, I will be able to help you with math definitely. What science are you
mhm.
taking?
Um I don't plan on taking chemistry. I mean, no, I don't plan on taking physics next year, but I'm thinking about taking chemistry.
Okay. If you're taking chemistry SL, I could probably help with that.
Okay.
All right. Okay. So if you need help with that, but I'm guessing we're gonna do mostly math either way, right?
Yep.
All right.
Cause I'll see. Cause sometimes she gives us like bookwork to do, and if
Mm-hmm.
there's anything I struggle on, I'll like send it to you.
All right. Sure. No worries. Okay. So with
Mhm.
this, yeah, okay. One more thing, since you said uh the break's coming up soon, that means exams are also coming up soon.
Yeah.
Yeah. All right. So again, let me know if you need help with the exams. Okay.
All right.
All right.
Okay.
All right. I'll see you next week again, and have a good day.
Mhm.
Bye bye
Bye
now.
bye.
All right. See ya. Bye bye.
Bye.
Okay. So that's the end of the lesson there. So hopefully, again, that helps you guys if you're going through some trouble with math. Okay. So with that, we'll end the stream. So don't forget to like and subscribe to Freaky Physics. Here on YouTube, Facebook, Instagram, Twitch, and TikTok. So, with that, thank you for watching, and I'll see you soon. I bid you all a good morning, good day, good afternoon, good evening, good night, wherever you are in the world, and stay freaky, everyone. Bye bye now.